And just get eyes up here. I just want to recap what we went over this morning, express my unhappiness with it. So I do want to show you guys a bit of a link that I missed in my explanation as well. What I showed you was correct, but there is one shorter way that we can think about these things. Okay, so it's important that you're having a look up here and listening in. So this is our vector A. We've found that it has a modulus of root 20, or a magnitude, modulus magnitude, size, length, root 20, meaning the same thing. And so this is the unit vector, isn't it? It's 1 on the magnitude A times vector A. And so that is going to be a vector in the direction of A that has a length of 1 unit. So if we want a vector that's 6 units in the direction of A, we're going to multiply it by 6. Now what we showed you was correct for C, but it was a very, very elongated way of doing it, okay? Probably the best way to think about it is like this. If I was to say 2 times the length of A, well that just means 2 vector A. And you know, if that's A, then this is going to be 2A, isn't it? That whole thing there would be 2A. And so then rather than going across 4 and down 2, it's going to be going across 8 and down 4. And so it's just doubling every value in there, okay? Similarly, if we're asked to find a vector that's opposite direction, so that means we're going to multiply it by negative because that changes the direction, and half, we're just finding negative half A. So we're flipping it and halving it. And so we're multiplying vector A by the scalar negative half, okay? So that's the fastest way to get to the solution. The process we did was fine, just a long way of doing it. Okay, let's have a look at example 3, which is find point P, find the coordinates of P, given it is 13 units from x is minus 3 and y is positive 2 in this direction. Okay, so let's think about the context for this. We have a Cartesian plane, we have this point which is x is minus 3, y is 2, and we're looking for this coordinate P, which is 13 units from it. Okay, it's 13 units from it. So if I was to draw, like, tie a piece of string to the pen and then, trace it around here, they're all the possible locations it could be. 13 units from it. But it says in the direction 12, 5. So meaning across 12 and up 5. Okay? So all we have to do is go across 12 spaces and up 5 spaces, and that's going to take us to the coordinate that we're interested in. We're at 3 minus 2, so if I go across 12 spaces from minus 3, across 12 spaces from minus 3, the coordinates of P are going to be x is 9, okay, I'm going across 12 spaces, and I'm going from 2, I'm going up 5 spaces, which will take us to 7. Now, sorry, that point should be up there, shouldn't it? It's got positive y, not negative. Anyway. So then we move on to 3G.2, where we're talking about collinear points. Now, collinear points are points that lie on the same line. Okay, they're lying on the same line. So what it means, if we have points A, B, C, they lie on the same line. It means, in terms of vectors, that AB is equal to some KBC, some scalar. Okay, they've got the same direction. That's what a vector tells us. And then we've got to multiply it by this scalar k for them to be equal to one another. So what we're going to do is we're going to find, we're proving that A, B, C are collinear. And we're going to do that by finding AB. We're going to find BC and then show that they're equal to one another by some factor. So firstly, this is what we did yesterday. We said AB is equal to OB take OA. Alright, so that's going to be this coordinate take away this one. So that's going to be positive 2 and minus 1 take 2, minus 3. Okay. For BC, we're going to be doing OC take OB. So it's going to be 4 take 0 and 1 take minus 1. 1 take minus 1, positive 2. Did I write those coordinates up there?
Isn't it negative 1 take negative 2?
Have I got B, but I've got B wrong, do I?
You've got A wrong. It's -2.
It's negative.
There.
Yeah.
Thank you. Okay, that'll explain all this as well. So here we have -1 take -2, that's -1 plus 2. That'll be +1. There we go. Okay, so then what we can see here is BC, well that's actually equal to -2 times 2 and 1. Isn't it? We can see BC equals we can pull that -2 out the front. And so we've got BC is equal to -2 times vector AB. And so because they're equal to one another by some scalar, therefore they are collinear. Okay, so we found AB, we found BC, and then we can see a direct relationship between AB and BC. Okay, I'll leave that one, finish this one. Okay, and our next example for collinear points says, find the coordinates of P. Okay, read it carefully. Find the coordinates of P given it divides the line AB in the ratio 1 to 2. It divides AB in the ratio 1 to 2. So that means AP is one part and PB would be 2 parts of this length here. Okay? So we need to find the coordinates of this point. We're told it lies on a line. So what this means is that AP, okay, AP is going to equal 2 times PB. That's our first statement. Vector AP equals 2 times vector PB. Okay? Because it's dividing it in the ratio 1 to 2. So then we need to find vector AP and vector PB in terms of x and y. So let's do that here first. Remember, AP is going to be OP take OA. If it helps, write it out and make the argument. So that's going to be x plus 2.
Because AP is 1 part.
And y take 4. Okay, so we've got vector AP. For vector PB, okay, let's do vector PB here. That's going to be OB take OP. So 7 take x. And minus 11 take y.
Be 2 AP equals PB, wouldn't it?
Yep, so we've got both AP and PB now, you're correct. We've got AP and PB, and this is the link we're making. So we need to make that statement that AP equals 2 times PB, 2 times this one. 7 take x and minus 11 take y.
Wouldn't it be 2 AP equals PB, not 2 AP equals 2 PB?
Oh, sorry, yes. Yeah. Two of these is equal to 1 of these. Yeah, thank you. 2 AP equals PB. So that means we need the 2 here, doesn't it? 2, yeah. So 2 times this length is going to equal PB. Alright, so let's multiply the 2 through, and then we're going to equate the horizontal part with the vertical part. So here we've got 2x plus 4, and we're going to have 2y take 8, and that's equal to 7 take x and minus 11 take y. Okay, and then we're going to equate the horizontal part with the vertical part. So 2x plus 4 equals 7 take x. Alright, so we're going to have 3x equals 3, x is 1. Alright, add x to both sides, subtract 4 from both sides, 3x is 3. And then for the vertical part, we'll have 2y take 8 equals minus 11 take y. So we're going to have, here, we'll have 3y equals minus 3, so y is minus 1. And so therefore the coordinates of point P are 1 and minus 1. So what do we have to do? We found AP, we found PB. We had to make the link in the relationship. 2 lots of AP equals BP. And then equate the horizontal and the vertical paths to find the coordinates. Okay, so we should be getting on to finishing 3G1 and making a start on 3G2.